Cpp.chat, an weekly look at what's going on in the world of C++, chatting with guests from the community, and now, matching our previous patterns, despite a few variants, John has a disclaimer to read.
Thank you, Phil. All the patterns on this podcast are free to use. You are allowed to sell products made from my patterns, but please clearly credit the design to us, Cpp.chat, and provide a link to our website, Cpp.chat. Permission is not granted for mass production or factory manufacturing of any kind. So, welcome, David and Michael. Nice to have you here, or virtually here.
Yeah.
So, I got to say, regular viewers will notice that I have a different background. I am speaking to you from the Gaylord Rockies, and I am able to look out my balcony and see. I can see downtown Denver. I can see Pikes Peak, and I can see Rocky Mountain National Park. It is a beautiful sight here. I think you guys should all come and join me.
Yeah, we'll be there soon.
Yeah,
I'll definitely give this some consideration.
Yesterday, we got the delivery of the T-shirts. It was an entire UPS truck. There are 45 boxes of T-shirts.
Wow.
So things are pretty crazy here. In fact, Phil had said, "John, are you sure you want to do a podcast right before the conference?" Oh, sure, no problem. I must talk to David and Michael. Sure, of course. And for the last couple of days, I said, "What was I thinking? What was I thinking?" So I got to wrap this up, guys. So let's get started.
Yeah.
All right. So as Phil hinted, I think we're going to talk about pattern matching and variants. Is that right?
That's what I was told.
Yeah. So who wants to kick this off? You want to start, Michael? Talk to us about. Are you going to talk about your talk at CPPCon or?
Sure. Yeah, we can definitely mention the talk. So just for initial reference of the pattern matching paper, the number is P1371R1, and so people can find the link to that. So I'm going to be giving the pattern matching talk next week at CPPCon. I believe it's on Wednesday. It's mostly will be similar to the talk that I gave at C++ Now, but it'll be a bit trimmed down and probably, not probably, I'll be discussing some of the design changes that were made in revision 1 compared to revision 0. And so look forward to that. So in terms of kind of the overview of, 10-second summary of what pattern matching is, it basically gives you the ability to inspect your values in a more declarative way. So rather than having some value and going through a bunch of if-else switches, if-else statements to lay out your Boolean conditions to look inside those values explicitly, you basically describe the shape of the value that you're looking for, and say, I want to execute these statements if this pattern matches, right? So rather than saying, for example, having a point class and an instance called P, rather than saying P.x equals 0 and P.y equals 0, you would just say match P with 0, 0 and see if that pattern matches, right? So you're describing your values as opposed to inspecting them explicitly. And so that gives you.
Are you telling the compiler at that point to create a temporary with that constructor values with temporary for it to compare?
No, there are no copies or temporaries being constructed. The patterns themselves only describe the conditions. Basically, it's a more compact form of the conditions. So you can think of it as kind of if you look at 5 lines of code of trying to inspect the shape of a string, right? You would do stuff like first of something, and then once you find that first thing, then you want to get the iterator to that and start doing more operations after that. So all of these become a sequence of conditions that you execute to try to find out what this string shape looks like. The alternative to do that is to describe your pattern in a regex, right? You describe what your string wants to, what you want your string to look like, and then you just test for a match, and also specify the captures if you want portions of that match in a string, right? So it's a similar analogy in that rather than explicitly testing for the conditions that you're looking for in a sequential manner, you declaratively specify the shape that you're looking for and just say, all right, go match this thing, and see if it matches. So that's the idea. And that provides the power to really cleanly describe, your selection statements compared to what we have today.
So there are a couple like examples that really hit home for people where pattern matching comes into play, because it solves several issues. Like, for example, if you, like, I don't know if you've ever felt the frustration of you have an enum and you want to switch on it, but you can't do that in an expression, right? Switches always have to be statements. So a lot of times if you want to, not necessarily do some imperative thing for each, case of the enum, but you just want to do some kind of calculation, and you'd love it if you could have const int I equals some switch and then have expressions in each one of those cases. So you can't do that today, and it's extremely frustrating, especially if you love, functional programming style and keeping things constant, removing the possibility of errors. So this pattern matching allows you to do that, right? So that's one of the common things, and like the other common one, which kind of, started this conversation, or was like a very important part of this conversation, is of pattern matching happening in the committee, is variant. Because so a lot of people love variant. It's like, hey, you should be using variant like all over the place. It's such a better way to model whatever kind of problems you have with types. Use variant. And then you get to where you need to do the inspect of a variant. You need to break it up into its individual cases, and it's just kind of horrific. And people who love variant, they're willing to go through that, right? And so, like, a common pattern that people use, you make a separate class and a bunch of call operator overloads for each of your alternatives in your variant. And people who love variant, they'll like, yeah, it sucks, but hey, at least I can model my type right.
Mm-hmm.
And pattern matching makes it so this doesn't have to be a separate class. It's in the code. It can be in an expression. It's what you would expect, especially if you come from a functional programming language or other language with pattern matching. It's just you put that stuff in line, and you don't have to go through this extra C++ machinery that feels really
C++. That's the luxurious C++. So
Yeah.
that's C++ with pattern matching becomes C++.
Yeah.
Yeah.
So in terms of the variant stuff, that stuff is actually very painful today. Like I've caught some discussions on Slack where people are literally asking, like, at what point would you start considering using variant? And the question is like, okay, why are you even questioning that? And the answer is usually because, well, std_visit which is the interface that you use to interact with variant,
right.
is very complex.
Right.
And one of the quotes that I kind of
syntactically
are very.
I don't know that it's semantically complex, but there's a lot of. It's simple what you're trying to do, but you have to write a lot of crap to get there, right?
It depends how much of the machinery you can look past, how much of it you can ignore, right? Because there's a lot of machinery involved, and you have to learn to ignore that. But yeah, so all of it.
And of course, that means you could mistype something. You could have cut and paste error.
Yeah.
When there's a lot of machinery, there's a lot of possibility for the machine to go wrong.
Yeah, exactly.
Well, fortunately, with the variant case, the going wrong means a compile error.
Yes.
More likely than like a runtime error.
Mm-hmm.
In most cases, probably. It's probably hard to get that wrong and still have it compile. Yeah.
Deciphering those messages is a different
figuring out what went wrong when something went wrong.
Yeah.
Well, if you use a visitor, it's compile time checked. But if you're just doing a sequence of if statements, you can check the type, and then you can actually try and pull out a different type, and that won't be checked at compile time. So linking those two things in a single operation saves you from that possibility.
Mm-hmm.
Robert Ramey in the chat, as ever, was criticizing this whole thing.
Oh,
But he's just wondering what the difference is really between just a chain of if statements. Is it just syntactic sugar?
yeah,
sure, why not?
essentially.
Yeah, I mean, just like C++ is syntactic sugar for C.
Yeah, there's a lot to be said about syntactic sugar, though. Let me see what he's actually.
Isn't that true of all lambdas? I mean, lambdas really are just sugar, right? I mean, there's nothing you can do with a lambda that you can't write on your own.
Yeah.
I did this once as a mental exercise, because one of the things that you can do with lambdas is if it's stateless, you can convert it to a pointer to a function. I thought, well, can you write that yourself? And I actually figured out, yeah, you can. You can have your functionality in a static function, call that in the object, and then return a pointer to it. So, with a conversion up. So yeah, you can do it. So if whatever a lambda can do, you can write code to do.
Robert was also following up in the chat, and I see Michael's responded to him, but it might be worth bringing it up here because he asked if there was a library solution that we could actually look at to get some sort of proof of concept. Do you know anything about that, Michael?
Yeah, so I just shared the link to my repo, github.com/mpark/patterns. That's the experimental library that I had written to get some design insights as to how pattern matching should look in C++.
And what previous that is the Mach 7 library with
right.
yarn. So, like as a library solution, this has been around for quite a long time.
Yeah.
Do people use it? I'm not certain that people use it, or I would recommend
macros.
But it certainly showed that if we want this, it needs to not be a library solution, right? We really need to have this baked into the language, and I think that's the conclusion that the committee has come to, like, pretty strongly at this point.
Yeah.
Personally, I'll say the same thing about variant, but maybe that's a topic for another time.
Or maybe not. Should we talk about variant as part of the language?
Sure. So that's actually the original context that this came up in when I got involved in pattern matching. So there was a big discussion about variant and what's the right variant for the standard library. There were a lot of different opinions there. Nevin Lieber gave a fantastic talk about this at C++ Now, which I will definitely plug. It's awesome if you want to see how the inner workings of the committee is. But
you don't want to see that.
I don't want to see that.
It's how the sausage gets made, right?
Oh, right. It's worthwhile. He doesn't show the most ugly parts of the sausage, I guess.
Okay.
So basically, one of the proposals that I had at one of these meetings was we really don't want a language-based variant. What we really want, we really want a language-based variant. We don't want a library variant. If we look at the most common use cases, and how variant is being used, usually the different type names of the alternatives that you put inside of a variant, they're just tags, right? That they're not really types in their own right. You wouldn't create an instance of these types. It's more along the lines of what you would see in a struct in a field name, right? You wouldn't want to have to make a different type for every field name in a struct. And if you look at some of the examples, it really just kind of shows that we kind of want a language-based variant. And so if you have a language-based variant, you definitely need some kind of pattern matching to inspect it. And so the language-based variant and the pattern matching and also an opt-in were all combined into one proposal. And that happened several years ago, and that was right before we voted variant into C++ 17. And so that got broken up into three different parts. One line of thought is the pattern matching, one line of thought is the language-based variant, and the other line of thought is an easier opt-in framework if you want to say you have one of these sum types that you would like to be able to pattern match on, and so on.
And what's the state of those? Are they all advancing?
Yeah. So the pattern matching is the most advanced, and Michael and I, we've been working on this along with a couple of other folks at Bloomberg to advance this forward, and it's gotten pretty far. through the committee at this point. It's an evolution working group. The language-based variant had an initial view in EWG way back in the day. It's now in EWGI, going back and forth on that. But basically all of this is kind of predicated on the pattern matching. The pattern matching needs to come first, and then these other pieces can come into the picture.
Because a language-based variant that you can't do pattern matching on is not really going to be very useful to you.
Exactly. You can basically set values and
right. There's no way to visit it. There's no way to inspect. Right. Well, yeah. Okay.
Yeah.
All right. Do you feel like the pattern matching makes sense if we don't do the language variant?
Absolutely.
Yes.
Still makes sense even for a library-based variant. It makes sense to do the pattern matching.
And every other thing in C++.
Mm-hmm.
Like literally every type. Maybe not literally every type, but most of the types that actually represent values, we can use pattern matching to inspect them in a clean way.
I mean, one of the things that's fun about this feature that may be different than, for example, concepts, is that this is going to impact every single developer. In new code, you are going to see this pattern matching in almost every single CPP file because it is useful in so many different contexts.
I do a TDD course. Did it just last week in Oslo. I'm going to do it again next week. And one of the examples I work through is this version of a Snakes and Ladders game. And there's a bit in there where I just need to return an object that can be in one of several modes. And depending on which mode it is, it will have different data associated with it. And because of the scale of this example, I'll just take the simplest direction, which is just to add all the possible values into a class, along with an enum. But as I'm doing it, I make the point that if we had a proper language level variant and pattern matching in the language, we could do this much simpler, much more cleanly. And in fact, I'd use exactly the same example in Swift, which does have exactly those things, and it is much nicer. So it is really a case of what you reach for first rather than what's possible in the language. There are different ways to solve the same problems, but the one that's cleanest and most expressive is the one that you really want.
So there's a question that Remy brought up that I think is probably worth addressing. The question was, what will the built-in solution do that the library solution can't do? And if you look at some of the examples that are written with the library solution, it's virtually unreadable. And the reason is because there's no syntactic difference between all of the different types of patterns. And so it ends up just being nested function calls, and you're left to decipher what all of these different names mean. And so, yeah, I mean, I would just say, like, go take a look at some of the examples which in the library solutions, which was good for experimental purposes. But if you actually were to try to read that code, it's very difficult. The second thing is there are opportunities that are available to us as a language solution that aren't as a library solution. For example, destructuring tuples, right? So we can construct tuples, we can construct structs with designated initializers these days, at least in 20. Where you can say, if you have members foo and bar, you can construct it by saying .foo equals something, comma, .bar equals something, right? Which is very nice. And then on the other side, when we go to destructure it, with pattern matching, what we're proposing is to allow putting .foo and .bar to extract specific parts of a struct, right? That kind of syntax and readability, we don't really have the opportunity to support in library solution, and so I think in terms of usability, it really has to be a language solution because of these kinds of things.
Generally speaking, before I'd want to see something in the language, I'd want to see a lot of library work. Has there been enough of that? Are we confident that we've got the syntax right? Because it's a lot easier to change the library than to change the language if you don't get it.
Yeah, and that's what I was trying to convince myself when I wrote the library is like I have some library chops. Let me really see if I can get something that really like works, right?
Mm-hmm.
And as far as like my skills go, I don't see how we can do much better than what I actually came up with in the library. Because the previous so there have been several attempts, right? The first one that I know of with that Yuri, Bjarne, and Gabby worked on was to use macros, and that's biggest reason why people don't use that. So my library doesn't have macros, but still, when you try to read through the patterns, it's very difficult. And I think having special syntax support for different patterns is going to be very important for readability.
And one thing that's nice is that pattern matching is not new to C++. There are a lot of languages out there. Pattern matching is new to C++, but not new to programming languages, right? So there's a lot of pattern matching functionality in various languages out there, and we've seen what works and what doesn't work in the decisions that they've made, and we tried to tie that into what we think would work well with C++ and the way that they approach problems and fit in the language as it is. And I think that the design that we came to is something that that strikes a really nice balance of integrating well with C++. It'll feel like it's always been there. It's not like some weird thing that just kind of got tacked on the side. But you get the expressive power that you need for the most common use cases, and even some uncommon use cases that you have what you need. So I'd recommend checking out the proposal. It's intended to be easy to read. There are a lot of examples in there, and you can kind of get the sense of like how we came to this conclusion of the ultimate design that we're proposing.
Yeah, I don't think there are any other languages that have pattern matching that also have the distinction between value types, pointers, and references that we have in C++, which is where a lot of the complexity comes from. I think even Rust it sort of boils away to almost nothing. And I think that's where a lot of your decisions have been evolving over the time as well. Is there anything you can say about that?
I mean, so probably like the most
that's a good point.
like important decision with regard to that was with relation to what do we do with pointers, because pointers are so ubiquitous with C++, that you want to have a pattern that you can use to get on the inside of a pointer and apply a pattern to the thing that it points to. And on one side there were a lot of arguments of the purity of like, hey, why do we need a special syntax for pointers? But and the other side of the argument is, well, this is C++. If you want to have a type which is a recursive type, like a node type in a tree that has two pointers to other nodes, you have to do that with pointers with C++. So not being able to support matching on the normal way that we would express trees in C++ would be like really unfortunate. So that's why like the design kind of like caters in that respect towards C++. But it's a really good point.
I think walking a tree structure using pattern matching is like the hello world of pattern matching examples. So the fact that once again C++ gets stuck on hello world is significant here.
So so whenever it comes up, people frequently ask about this pointer pattern, like we don't need it. And so we have one particular example in the proposal, which is red black tree rebalancing. And if they have any kind of question about it, just say, look at that example, because you can express red black tree rebalancing in such a compact and expressive way with pattern matching. If you were to do it without it, it's just like absolutely hideous. You lose complete context of what's going on.
And of course, people will then say, yeah, but nobody has to write their own red black trees these days. Well, I've done it twice in C++ and at least once in a language with pattern matching. So I'm right there with you.
Nice.
One of the, well, back up a bit. I saw you presenting your pattern matching proposal in San Diego the first time,
Mhm.
and there was some aspects of the syntax that overall it seemed really nice, really nicely done. But there were some aspects of
Thank
the
you.
syntax that I really couldn't get behind, and I
Okay.
think you significantly changed exactly those things for Cologne. I didn't see you in Kona. And that was particularly to do with how you distinguish between identifiers and binding existing names, if I remember rightly.
Yes, that's correct.
It's obviously a little bit hard to talk about it without the text, but is there anything you can say about that? Because I know some people saw the older syntax.
Yeah. So yeah, this is something that I'll cover next week in the talk. But in short, so the core of the issue basically is when you have an identifier inside of a pattern, does that identifier mean that it's a new identifier, or is it referring to an existing identifier, whether that be a variable or type or whatever? So before, what we had, the syntax that you were mentioning you didn't like, Phil, was the caret syntax, right?
Yep.
So we had caret followed by expression. And so if you had caret x, then the x meant that it was an existing variable. If you just said x, then it was a new variable. And the whole point of trying to put a disambiguator there was because we wanted patterns that maybe look like expressions, right? So like we wanted the room to be able to later introduce 1 bar 2 as a pattern that says match 1 or 2, right? Not perform bitwise OR and then match the result of that. And so that was the room that we were trying to, carve out. And funnily enough, when we went to Kona with the patterns that looked kind of like expressions, every one of those on separate occasions was shot down and said, this is very confusing. This looks like an expression. This is doing something different. Why are we doing this? And so we said, okay, well, if we're not going to want patterns that look like expressions anyway, then let's just not worry about carving this out, and we'll just do something different for patterns. So now the design is to say, if you say, oh, and the other thing is, if you look at a simple case, right? So it'd say like inspect a enum, and let's say we have like caret red, caret green, stuff, right? Every time I show this example, I have to explain to people what the caret does. So now what you can say is case red, stuff, and case green, stuff. And so the way it works is there's a case pattern where you can say case followed by a pattern, and any identifier that appears in that pattern is an existing identifier. And so in the simplest case, if the pattern happens to be just an identifier, in the case of red and green, for example, then you can just say case red, stuff. And that means the enum that you had above. And so that example, I don't have to explain ever, right? I just show it to people and they're like, okay, I see what this is doing. And without the case is when you would introduce a new name. And so if you were to just say red without the case, then that would actually introduce a new variable, not a variable, sorry, a new binding that binds to the value that you're matching. And so that's how we've gone to distinguish between patterns and expressions, where patterns will just have different syntax than expressions, and we're left to disambiguate identifiers. And identifiers are disambiguated by either being within a case or a let. And so you can also say let red stuff. And so red there is a new identifier. And at the top level, let is implicit. And so that's why you can also say red stuff, and that'll be an implicit let. And so it's a bit hard to describe without examples. It will be much clearer with examples, but I hope that clarified a little bit.
Well, obviously, I need to go to your talk to see the examples.
Yeah, that would be great.
I'll be there.
I gotta say that, like, this design that we ultimately ended up with, we went back and forth quite a bit. I think it's like super elegant. It integrates really well with the language. You'll see the harmony with switch statements right away with it. But we kind of came to this conclusion like the night of the mailing deadline, and I didn't think we were going to be able to get this in time, but Michael's like, I think I can do this. Go for it, man. And he did, and it came out really well. So thanks, Michael. That was awesome.
Thank you.
Are you showing off San Francisco back there?
I was trying to fix the lighting a little bit, but it's a bit it's fine.
Yeah.
But yeah, it's pretty out there, right?
Yeah.
Yeah. Yeah, so that was a wild night. That was late night, but I'm pretty happy with where we are now. Yeah.
Sometimes those artificial deadlines create magic. That something has to happen, and it has to be simple, and it kind of has to be simple and elegant, because we don't have time to do something complicated. So you got to think about a way to make this work.
Yeah.
Unfortunately, it also causes people to do stuff that is not good.
That's true.
So it's not always great, but when it's great, then we can all celebrate it. So you're going to talk about this here next week.
Yes.
What are you going to be talking about, David?
So I'm actually not going to Cpp.chat this year.
What? Who thought that was a good idea?
Well, my wife for one, but yeah, I will definitely be there next year. But because I looked at the lineups, some of the people on my team are coming, and they sat down with me and said, hey, what talk should we go to? And went through the whole agenda, and it's just an awesome lineup. I'm super excited for everybody who's going to this conference. It's going to be amazing.
Yeah. It's pretty tough to do your personal schedule, which is what we of course encourage everybody to do, but it's not going to be, I sent out an email to all the attendees and I said, follow Kate's recommendation. And she says, pick your schedule and always pick a backup, because if you're sitting in there and the first couple of minutes you realize this isn't really what I thought it was, then already where your alternative is. But the hard part is not picking two. The hard part is picking only two, right? Because there's just a lot of good sessions going on. I was asking somebody last night at dinner about when their session was, and I just pulled it up on my phone and I was going through the app, and it's like, oh wow, you're really up against it, aren't you? And it's like, but that's just, every hour there's really good talks on a lot of exciting stuff going on. And I was looking, one of the things that I was looking at is kind of the diversity in kinds of talks. I mean, there are people talking about new features, but there's also people talking about essentially, case studies of, well, we tried to do this and how this worked out. And there's people who are talking about, one of the tracks we have is this back to basics, where people are basically saying, well, here's what you need to know about, and then fill in the blank. Here's what you need to know about exceptions. Here's what you need to know about. In my case, I'm doing a talk on object-oriented programming, which was kind of a tough sell to get people to think we need to talk about object-oriented programming, because that's just so 90s. It is not the cool kids' new stuff. None of the cool kids are talking about object-oriented programming. But I know from my training work that the vast majority of people out there are supporting legacy applications and doing object-oriented programming. And if we're not talking about how to do that right, and it's not new stuff, right? I mean, this is in my talk I reference Scott's books and Herb and Andre's books that I'm not rolling out any new great insight. But if we don't talk about it, then as people come along and have to relearn things the hard way, rather than us saying, well, this is kind of guiding principles. But there's all sorts of different talks. Some of them are how best to apply the new features, and then some are focused on the features themselves. And so kind of it depends on how much community understanding of a feature is, and where we're at in terms of best practices on those things. So, and in an awful lot of cases, the talks are by the people who are authors of the features, which gives an interesting insight and an opportunity to ask questions that someone describing how a feature is in the standard, you can't say, well, why didn't you do this to that person? Because
Right.
Well, I'm sure they thought of it, and I'm sure there's a good reason, but I don't know what that is, right? But if you have the author there, you can say, and then they can say, well, you know, actually, at one point we did go down that road, and here's why it doesn't seem to work out. Those are the kinds of insights that often don't get documented, but are really insightful when you can ask the question and get that response from a live person. Because, you know, I mean, people don't always want to document all the blind alleys and say, well, you know, we went down this, it didn't really work out. But when you ask, you say, well, that seems obvious to me. You do this. And it's like, well, yeah, it is obvious. And it works really well until you get to this situation. And then, no, you don't want to be there.
Yeah.
I must say, John, like with your object-oriented talk, when I saw that, I saw the title first and I was like, probably not too interesting. And then I saw your name and I was like, hey, you guys should go check out this talk.
Yeah.
It does remind me of a talk that Walter Brown did in Rapperswil after one of the WG21 meetings there. So we had the whole of the standards committee, the C++ standards committee, going to this talk on templates or function templates. And that was all it was about, from basics. And you could see a lot of people at the start of the talk thinking, yeah, I'm not going to learn anything from this. And by the end, everyone was saying, well, I actually learned something from that. And just couldn't believe that they could get something from a back to basics talk being pitched to the standards committee.
To the standards committee, yeah. Well, you know, I've learned a long time ago that I can go to a talk that is something that I know that. And sometimes I will even come out of it not being able to tell you one new thing I learned, but instead saying, well, what I got an appreciation for is a new way of looking at it and a new way of thinking about it altogether. And a lot of times that's what you get. It's not that there's some fact that I didn't know the compiler does it that way. It's not that. What it is, I never really thought about it that way, but yeah. And if you think about it that way, you can reason about your code in a different way. And sometimes, I think I have great hopes for the Back to Basics tracks. In fact, I noticed that some of them are going to be in some of our bigger rooms because they're kind of popular. And I really think that, I mean, I don't want to get away from, absolutely, we want to talk about things like pattern matching and things that are not quite here yet. And let's get a discussion about it. Let's get ideas about it. Let's make sure that it makes sense and build some acceptance for it. We should absolutely do that with new stuff, but we should not ignore the fact that the vast majority of people out there who are C++ programmers are not living in the future. They're living in the past, and they can be in a lot of pain if they're not following best practices. And if we've got some best practice that's sitting in a Scott Myers book that nobody's looking at because it's pre C++ 11, that's not doing anybody any good. Right. So that's why I dredged up for my talk. But there's others other back to basics that are not as old. They're looking at some modern stuff, but again, looking at it in terms of, here's the back to basics on move semantics. And, we've all heard move semantics a million times and it's all been done to death, but to get a nice fresh perspective of this is what you really need to know. It's not the esoteric stuff. It's what you really need to know. I think that's going to be really beneficial. And so,
yeah, I agree.
Yeah. And now
sorry, I was gonna say, remember the future stuff always relates back to the old stuff. So related to your object-oriented stuff, like pattern matching will work with object-oriented things, right? It's one of the important cases that we need to support because it's already in the language and people are using it a lot. And so being able to match on a base class and specify your derived classes as your cases is one of the cases that are one of the patterns that are supported. So it'll be relevant.
Yeah, that is interesting. It's very interesting to think about that. I think
in fact, it offers a whole new type of polymorphism, which is not v-table based.
Does it?
Yeah, well, that's really what a variant, and particularly if we get a language level variant, that's what that gives us, is the way to represent objects that can be in different types of state that you can then have different behavior attached to. And it's just flipped around from the v-table based approach where you have to always implement every method for every derived class.
Right.
And in this way around, you separate the operations from the state, but it's It's still polymorphism.
Yep.
I think
Right.
I'm really sold on this pitch of the back to basics. That's I mean, that makes so much sense, right? Not just to help out people that are out there, but to broaden our community outreach, right? We want to get a broad audience of C++ developers, get new C++ developers into the community. And if we don't have a path for that to happen, then it's not. And, the C++ community will just age out. So yeah, I applaud this effort. I think it's a great idea.
Yeah, we had somebody on the there's a Slack specifically for attendees, and somebody was saying, well, my plan is to just go to all the back to basics tracks, or all the back to basics sessions. And I said, well, that's great, but please at least look at all the sessions, because you don't want to find out afterwards that there was this one session that people were talking about afterwards. It's, oh, if I'd known, right? So do take the time and look at everything. And there's nothing wrong. I think the back to basics track was envisioned as exactly that. For certain people, that's what they need. That's going to work really well for them. So I'm certainly not saying, oh, whatever you do, don't do that. But don't close your mind to that. You do look at the alternatives. And I think that there's a lot of people who will look exactly that. I'm kind of curious about how it's going to be received and how we're going to do it next year. Are we going to kind of repeat the same sets of things? I don't know. We're gonna have to see. We'll see how it's received. And maybe what we'll do is we'll have the exact same thing. Here's back to basics on exceptions, but it's done by somebody else, and you get their point of view on it. Because one of the things about the back to basics track is I pitched this as an idea mostly to people who were our instructors for the pre-conference and post-conference classes. Now, it's not exclusively to that, but that's who a lot of it was directed to, because that's essentially what instruction is, right? I mean, it's kind of, as instructors, we talk about new features and all these kinds of things, but we're really saying this is how you write code. This is the whole picture. And so there's a lot of back to basicsness in training materials in general. And so that's where we worked at. And in fact, as the different instructors were talking about that, there were a lot of people who were like, well, yeah, I kind of could do that. Oh, no, well, you do that one, then I'll do this one, So it might very well be that we do the exact same topics next year, but they're given by a different instructor, and it might be a completely different session, and you're going to get something special out of it. So maybe that's the direction it'll be. I don't know. We'll have to see how it's all accepted, but I'm really excited about the approach, because I think there's a lot of people out there who we are reaching through videos more really than showing up at conferences, and we need to think about how best to serve them. And,
you can stress over that in about 10 days.
Yeah. So what else do we want to cover?
Well, we actually have quite a few news items that have been building up
because
we've been missing them for the last few episodes.
Okay.
I don't know if we want to get through them all now. Some of them may be a little bit stale. For example, I wanted to point out the post-Cologne mailing is out, but that's at least a month ago now. We've actually been covering some of the proposals from there. John, do you have any more about CPPCon that you wanted to announce? I know this probably won't come out before it starts, but
right. Well, Tool Time is the announcement that is just most recently. We're repeating what we did last year, which is an opportunity for people to have. I think of it as kind of, we have exhibitors, but those are people who, for the most part, are making money selling a tool. Some of our exhibitors are actually doing recruiting kind of stuff. So other than that, but for people who are talking about tools, we're talking about people selling tools, and they'll get a table or a booth, and that's great. But there are people who I feel like, and I was basically thinking about this in terms of, if I had a question about how do I set up continuous integration, we don't really have a vendor that's selling continuous integration. What I would like is to talk to somebody who's done this and got, wants to be a Jenkins champion, or, some kind of tool that does this. And so that's why we said anybody who is willing to champion some tool for one session, and it's informal. You don't have to give a presentation. What happens is we just have a bunch of tables out there, and people will come along and say, well, yeah, I have some questions about CMake or Jenkins or whatever the tool is. And so that's what it's that's what it's about. And how many people did we have last year, Phil? It was about, was it on the order of a couple dozen?
I think not even that. I'd say closer to a dozen. Separate
Different
tables.
tools.
Yeah.
Yeah. So we've got interest again. I'm not sure what the number is, but it's on the order of that at least. I think the last time I looked at it, there were 9. And we've still got, that's going to be on Tuesday night. So that's one thing we want to announce. I think the other things that are, like you say, by the time this goes up, they will have been old. We have a book from Nico Jositis that we're giving, or Usitis, I should say, that we are giving a free download to all attendees. And we also have a, that's for his C++ 17 standard book. And then Bartek, what's his last name? Starts with an F. I know his last name. But yes, and he's written C++ 17 in depth is the name of his. And we're going to have some of his books to sell, but we're also going to have a special offer that's not quite a giveaway, but a really, really generous offer that he has given for people buying his electronic book. So, so we've got some good things for attendees. There's going to be a few surprises.
Awesome.
Speaking of booths, there's one booth which I'm super excited about. And that's the Bloomberg booth. So if anybody would like to come and check out the Bloomberg booth, we're going to have engineers there the entire time, Monday, Tuesday, and Wednesday, to talk about like the things that Bloomberg does and like the various positions we have available. We got like awesome stuff going on here. So just saying, since you brought up booths, I figured I'd slip that one in there.
Well, I should tell people, people who have never seen a Bloomberg terminal. So my bachelor's degree is in finance. So to me, a Bloomberg terminal when I was in school, that would have been the most amazing thing in the world. I take that back long before that was possible. But the ability to sit at a Bloomberg terminal and just call up amazing financial information and then slice it and dice it in just the most incredible ways. That's just an amazing toy to play with. And then, to be programming in that world, we have, access to all that kind of stuff. It's pretty cool. And I guess you can go to the Bloomberg booth to see the terminal and then talk about playing in that world.
You should definitely check out the Bloomberg booth and many of the other booths on your way to the JetBrains booth. I will be running some demos on the JetBrains booth next week, so come along to see those. We're also going to run a quiz, and we're going to announce the winners of that and give away prizes during I believe we said the Thursday morning recording of CPP.chat.
Yeah, should we tease them about what we're planning to do, what CPP.chat's going to do at the conference? Should we tease them? Should we announce it? What should we do?
Yeah, did you put it in the schedule yet?
I don't have any names in the schedule.
Okay, then.
I just have a session. We're going to do a session on Thursday morning and a session on Friday morning. So we'll do a live audience session for CPP.chat.
Yeah, we couldn't find anyone particularly high profile, so we had to settle for Andre Alexandrescu and Herb Satter on Thursday. And then on Friday, we're going to have Sean Parent.
Right.
So hopefully they'll be up to the job.
This will tide us over until we can get some big names.
Yeah.
Yeah.
So if you come along on Thursday morning in particular, we'll announce the winners of the JetBrains quiz.
Cool.
So what kind of quiz is it?
As far as I know, because I haven't looked at it myself, it's this is one of our C++ brain teaser type quizzes.
Right. The kind of thing that if you had your IDE, it could tell you the answer real easy.
Well, that's something you can try out.
Or if you have Richard Smith with you.
That would be cheating.
Yeah, it's too bad we can't all just have our own little Richard Smith.
There's a title there.
There's a title there. That's right.
So have you guys heard of Circle Lang?
I don't think so.
I have not.
So there's a tweet that was shared in the Slack chat about a guy named Sean Baxter, who actually told David and I about his implementation of Circle Lang, which, as far as I understand, is like extensions to C++. And so he implemented basically like all of C++, standard C++ up to 17, and he's adding a bunch of different like features on top of it. And he's planning to implement like official C++ 20 and everything. And he implemented a prototype of pattern matching as like roughly as we proposed. And so you can see like an example of what he did in Circle Lang, which looks pretty good.
Now, wait a minute. What is this? This is somebody implementing a C++ compiler as a hobby?
Yeah. Well, I don't know about hobby. I don't know, but he seems to be doing it alone. It's pretty impressive stuff. like what? I was reading the email. I'm like, sorry, you're doing what now?
So
yeah.
you guys definitely should have him on the show. And the way he described this project is, this is all the C++ 30 features, but right now. Like, he's got full reflection. I mean, it's incredible what he's done with this thing. So yeah,
maybe we can get him on before Rob and Jason for a change.
It's pretty impressive.
Yeah, let's reach out to him and find out what he's doing, because I always want to give a microphone to people doing crazy things, and this sounds like a pretty crazy thing.
In any case, I'll put a link to that in the show notes.
All right. Well, so I guess it's time to wish everyone safe coding. Unless was there another news item that we want to talk about, Phil?
There are actually a couple more.
Oh yeah, let's do those then.
One was because in the last episode with Patricia Oost, we talked about her keynote, and as I pushed her episode online this morning, the keynote came online as well. So I added that to the show notes retrospectively to her episode, but I'll add it to this one again, so you can go and see that. And another thing we've been putting off for a while, well, not putting off, but just not getting to it, was I just wanted to mention that we had a ReSharper C++ release over a month ago now. And that has a load of extra C++ 20 features supported in it. So if you're doing any C++ 20 work, then that'll be worth checking out. Also,
and you can drop by the JetBrains booth to ask them questions about it.
That goes without saying. There's also got enhanced Unreal Engine support. So again, if that's something you're involved with, then check that out. And of course, all the usual improvements and performance boosts and things like that. So yeah, wanted to get that out, but just before we get to the next release.
Yeah, that's right. Stay on top of those.
Wait, Phil, so what is ReSharper? Like, what does it mean to have more C++ 20 support?
Okay, yeah, so ReSharper C++ is a plugin for Visual Studio, which gives it extra IntelliSense features, code navigation, refactoring tools and things. So it's all the extra support on top of Visual Studio, as opposed to C-Line, which is our fully standalone IDE.
Okay, cool.
And the one other thing that I did promise that I'd bring up when it came to it was the CPPP. That was the Paris conference from earlier this year. Their videos are finally coming online. They're trickling through. So I'd say like one a week or less at the moment. So keep an eye on that channel. There's a few up there now. Again, I'll put the link in the show notes.
Okay. And did you want to talk about your more productive with test-driven development, your blog post on level of indirection?
Yeah, well, I thought I'd put this up because I've been doing this course on TDD for a while now, and I say doing another one next week at the end of CPPCon, so there's still time to sign up for that. So I thought it'd just be worth just putting a post up about what I'm covering in that, and what my perspective is on TDD and why I think it will make you more productive. So I can put the link to that in the show notes as well if you're interested. If you can't make it to CPPCon for that, then I'll be doing it at other places as well, I'm sure.
Cool.
Well, I want to thank you guys for joining us today.
Yeah, it was fun.
Thanks for having us.
Thanks for having us.
Thanks for coming on.
All right. Well, from really all over the world, we're representing New York and London and San Francisco and Denver, I guess, here, right?
Mhm.
So from all over the world, we're coming to you and wishing you all safe coding.
Safe coding.
Say coding.
Safe coding.